Hello and welcome, friends. So, today we are going to talk about one more topic that we covered as fundamentals in the previous session, which is simple interest and compound interest. So, this is like I mentioned in the previous session, this is one of the areas of your MBA entrance exam like CAT, NMAT, SNAP, IFT kind of an exam, where you see a couple of problems coming directly out of that area. This area as a whole may not have a lot of cross application in other problems, like hardly a data interpretation set you will see applying SI and CI knowledge. But this is one area where in itself you see direct SI/CI problems, couple of them in MAT, SNAP. I have to kind of an exam, possibly one or sometime two in CAT as well. So these are areas where it requires mostly concept and couple of formulas that we covered in the previous session. If you have not gone through it, I will put them in the description box, the link of the previous session. You possibly go through it. So like we do for every topic, we start with a fundamental session followed by a problem level 1 session, where we cement the fundamental understanding and do some of the level 1 and very few level 2 kind of a problem, and just to warm you up for the last session, which is basically the advanced level session, where we typically solve level 2 level 3 kind of problem. So that's the pattern we follow for every topic. As you may be aware, if you are seeing my videos for last few months, you will possibly able to understand the pattern, and that typically 3 sessions on each topic. So this is the second session for SICI. The first session was on the fundamentals, and this is the second session where we will do problem level 1, or the foundational problem that will help you understand the concepts that we have covered in the previous session, both from simple interest as well as compound interest. So without further ado, let's get started. So again, one more thing, like I said in every problem session, if you see the problem, don't continue the video right away. Pause it. Try to solve it by yourself. If you was stuck, take 3 minutes around to solve it, and then if you are stuck, you can come back and see the solution. Or even if you solve the problem, come back and see the solution how we have solved, and see if you have got the right answer or not. If you have difficulty in solving, you can come back, and if you have, like I said, if you have solved it also, come back and check the solution. But just don't continue seeing the solution by yourself, so that you will get practiced when I'm doing it by here. So without just seeing the solution right away, just try your brain, try to think on how you would have spent time on solving it, and then come back and see how is the optimal way of doing it by seeing the solution that is followed. Okay, so let's get started with the first problem. Just a minute. Okay, so if you can see the problem, it says a certain sum that was lent at simple interest. So important thing is it's a SI problem, or it's a simple interest problem. A certain sum that was lent to simple interest of 25,000 in 4 years and 30,600 in 7 years. Find the sum as well as the rate of interest. So what is the SI formula we know? We know that interest is principal into rate of interest into time by 100. This is the formula. So in the first case, this is its amount to 25,200. What is the amount formula? Amount is principal plus interest. So interest, from here I can say interest is amount minus principal, right? So if I have to use this formula, I will write in the first case 25,200 is the amount. So 25,200, right? Now you can use this formula directly. I'll show you both. 25,200 minus P is the interest, and that equal to P into, first is used in 4 years, P into 4 into R by 100, and the second one you can say 30,600 minus P P into 7 into R by 100. So if you divide the first equation with the second equation, you will get P and R cancelled out. You will have P as the unknown and you can solve it. We can do it that way. So what I'm trying to say is, if this is equation 1 and this is equation 2, so we do 1 divided by 2. So we do 25,200 minus P, 30,600 minus P, equal to 4 PR. 100 will get cancelled, divided by 7 PR. So in the PR will get cancelled. So there was 100 here, there was 100 here. They will also get cancelled. So 4 by 7, you can cross multiply and solve it for P. So that's one way. But what we will do here is, we will not go typically that route. We'll see if there is a simpler way to solve this problem. So this is one way. The other part is, it's a simple interest, right? So simple interest means interest is same each year. So your interest is going to be same for each year. Now for 4 years, it is 25,200, the amount, and 7 years, the amount become 30,600. So amount is comprised of principal and interest. Now your principal is not increasing, so your interest is only increasing. So can I say for 4th to 7th year, that means the 3-year, your interest is 30,600 minus 25,200, or I can say it is 5,400 rupees for 3 years. So for 1 year, your interest should be 5,400 divided by 3, or 1,800. For each year, your interest is 1,800. So interest is same because your principal remains same for simple interest. So it is 1,800 for each year. So for 4 year, your interest will be 7,200. 1,800 into 4. Again, 7,200. So that means your principal is amount minus interest. So after 4 years, your amount was 25,200 and your interest is 7,200. So your principal is 18,000, right? That's the one way you can calculate your principal, right? So since we have calculated the interest for 3 years, for 4th to 7th, and considering that interest is same, we calculated the per year interest, and per year interest is this much. So for 4 years, the interest will be 7,200. And from that 7,200, we can calculate the principal by subtracting from the amount. So this is one way of calculating the principal. Now they have asked for rate of interest. Now that should be fairly simple. So if you know this, then in 4 years the total interest is 7,200. So if I apply this formula, so 7,200 is the interest. Principal we know, principal we know, that is 18,000. Don't know R, you know T for 4, you know this is 100, so 100 get cancelled. 4 is 1,800, so R is 1,800 by 180, 10% per annum, right? So you can do this also. So you know R and you know P. So this is your answer. Yeah. If you have any doubt, any suggestion, any where you are lost, you just drop a note in the comment section and I'll be able to respond from there. Let's go to the next problem. A sum of money invested at simple interest triples itself in 16 years. So if you have principal is X, your amount becomes 3X. Now simple interest, so that means your interest must be of 2X. A sum of money invested in simple interest. So triples itself in 3 years. Triple itself means the amount becomes 3 times. So if you have invested 100 rupees, your amount becomes 300 rupees. So your interest must be 200 rupees because the principal is anywhere there. So it triple itself in 16 years. So just applying the formula of simple interest. So 2X is the interest, X is the principal. The rate of interest is what you need to calculate. Time is 16 years. and this is by 100. So if I do this, R becomes 200 by 16, or I can say 100 by 8, or 12.5%, right? So R become 12.5%. If the interest rate is increased by 3.5%, so new R, that means 12.5 plus 3.5 should be 16%. So if R becomes 16%, how many years will the sum become 5 times? So X become 5X. That means your interest is of 4X. So your principal is X, your amount is 5X. So your interest must be of 4X, right? So we can apply the same formula, 4X interest. X your principal, R you know 16, here you don't know T, you calculate this. Okay, so X gets cancelled. So T is nothing but 400 by 16, or if you divide by 4, so this is 100 by 4, it is 25 years. So the answer is of 25 years. Yeah. Again, drop a note if somewhere it's unclear. Let's move to the next problem. If the compound interest on a sum is rupees 75,000 at 10% per annum, 40 years, 24 and 25. Let's try to do it. So there is one formula of compound interest where we know amount P into 1 plus R by 100 whole to the power T. But it's getting to be a complex calculation because you have to find T, which is in the exponent. So that's not an easy calculation in a normal way. If you have access to calculator, you can use that. But let's try to see if you can do it some other way. So just apply the basic concept of compound interest. So your principal is 75K or 75,000. Interest rate is 10% per annum. Interest rate is 10% per annum. This is the total compound interest is 24,825. Okay. Then in year 1, I can say my interest rate is 10% of 75,000, or I can say the interest rate is 7,500. Total interest for year 1 is 7,500, right? In year 2, what will be the interest? In year 2, you will get interest for this principal plus this interest, right? In year 2, then compound interest to the sum 40 years, 24,825. First, you have earned this much interest. In the second year, you are going to earn how much interest? You are going to earn anyway 10% of 75,000. That is by default because that is the principal. Plus, you are going to earn 10% of 7,500 as well, because that interest is now added to the principal, previous year's interest. The basic concepts of compound interest, the interest you earn in the previous year will get added to the principal, and you will get interest in the next year for both principal and the interest of the previous year. So in second year, your interest becomes 7,500 plus 750. Or we can say this is going to be 0.5288250, right? So this is your interest. Okay, so how much is the total interest you have earned at the end of year 2? So end of year 2, your interest is 7,500 for first year, 8,250 for second year. So this is 15,750 is your interest. You have to go to 24,825. So let's see another year. So year 3, what will happen? Your interest 3 is again 10% of 75,000, which is given. So that is 7,500. That is anyway coming from the core principal. Now the total interest you have earned 15,750. You will earn another 10% of that. So that is 1575 rupees. 1575, how we got? It's 10% of this value. Because of this total interest that you have earned at the end of year 2, you will get interest on top of that also. So 7500 plus 1575 makes it 9075, right? Now let's see what is your interest at the end of year 3. So end of year 3, you had 157750 for last 2 years, 9075 from this year. So it should be 524,825. So in 3 years, you should get this much amount of interest. So first year you got an interest of 7500, second year you got an interest of 8250, and third year you got an interest of 9075, total 24825. But yeah, we applied the very foundational concepts of compound interest and we tried to solve this problem. Okay, any doubt, anything, please feel free to drop a comment. Going to the next problem. This is the compound interest on a certain amount at a certain rate of interest for the third and fourth year was 11,520 and 13,824 respectively. Okay. Third year and the fourth year. Okay. So I know compound interest, if you calculate the difference between they said on a certain amount. So interest for third year is 11,520 and interest on fourth year is 13,824. So the increase in interest from third to fourth year is because of the interest that you have generated in the third year. Because otherwise everything remains same in the third year and the fourth year. The only difference is the interest that you have earned in the third year. So now this 11, if this 11,520 was not added to your principal, your interest rate in the fourth year would have remained same. Because of this 11,520 added to the principal and it's a compound interest, your interest in fourth year is increased to 1384. So can I say then R percent of 11,520 R being the rate of interest? So rate of interest of 11,520 is nothing but 1324 minus 11,520, because this is the extra amount that you have earned because the rate of interest is calculated on calculated over 11,520. Because this 11,520 was not included in the third year principal, but it's included in the fourth year principal. So your principal is increased by 11,520 and that's why you earn that extra amount in the fourth year. So first let's calculate this. So R by 100 into 11,520, this is 2304. Okay, so you can say R is equal to 2304, 00 get cancelled, by 1152 into 10. Okay, so this is 2, this is 20. So R is 20% per annum. Okay, so this is the value of R. So again, don't get overwhelmed by compound interest. If you know the foundational concepts or the basics of compound interest, you will be able to solve a lot of problems with this only. So like we did, we calculated the 3 years interest. We know the fourth year interest. So that means the delta that is created, the extra amount that is generated, is because of the interest generated on the third year. So if we apply the normal percentage formula on R percentage is the interest rate, and that is applied on the third year interest to create that extra amount. So we calculate the extra amount is 2304, and from there we calculate the R. Okay, any open area, any doubt, please drop a note in the comment. Okay. Go to the fifth problem. Okay, when you are dropping a comment and just drop a question number, like this is the fifth problem, or you can see the question number in the top, and then if this is 5, then you can say we have put in the this is the fifth question. Okay, now go to the next problem. If the difference between the simple interest and compound interest on a sum of money 15% per annum for 2 years is 360. So what is happening? So this is a mix of simple interest, compound interest. So in a simple interest, what will happen? Your interest for first year, interest for second year is the same, right? For compound interest, your interest for first year will be same as the interest for simple interest, plus this will have in the second year, what will you have? You will have interest what you have generated in the first year plus 15% of interest. So this is the extra amount, right? So this is the extra amount in case of compound interest, because the first year interest and second year interest is same for simple interest because the principal is same. In compound interest, your first year interest is from the principal. Now second year, that interest so anyway will be there. But the interest that you have earned in the last year will also earn interest. So 15% of last year interest is also gets added. So can I say 15% of first year interest is 360 because that's what is creating the difference, right? So can I say I is 360 into 100 by 15? So this is 2400. Your interest is 2400, right? So this is so if your interest is 2400, then find the sum. So the sum or the principal, if we can apply, so 15, your first year interest is 2400 at a rate of 15% per annum. So 15% of your principal is 2400. So your principal becomes 2400 divided by 15 into 100. Means 16,000 is the principal, right? So your principal is 16,000. Okay, any doubt, please have a note. So go to the next problem. The next problem is saying if the simple interest on a certain sum of the money at the end of 2 years is 756. So simple interest for 2 years is 756. So for per year, it should be 756 divided by 2 because simple interest gets calculated in the same way. So it is 378. And the corresponding of compound interest on the same sum is 864. So compound interest, like I know, it will be 378 for first year. In the second year, it will again be 378 will remain same plus R percent of 378, R being the rate of interest, right? So this is 864, right? So can I say 378, which is coming out of the core principal, plus 378 plus R percent of 378 is nothing but 864. This is nothing but your 756, the first two values. So R percent of 378 is nothing but 864 minus 756 or 108. So R by 100 into 378 is 108. Okay. If you do by 18, so 18 by 6, 21, right? Do by 3, 3 by 2, 7. So R is 200 by 7. Okay. R is 200 by 7. What is the sum of rate of interest? So rate of interest you got per year SI is 378. So let's apply that. So I equal to PRT by 100. So per year simple interest is 378. So 378. So this is one value you got. 378 P into R, which is 200 by 7, into T, which is 1 year, by 100. So this is 2. 2 by 370 is equal to 189 into 7. So 1323. Just give me a minute. If I'm doing it right now. Yeah. So your rate of interest is 200 by 7, and your principal is 1323 rupees. Okay. So that's what we calculated. So 7. So what we did, we know simple interest for 2 years is going to be same 756 by 2. So 378 is per year interest rate. And then we calculated from there what is the CI, because of the CI for the first year is 378. CI for the second year will be 378 plus R percent of 378. And that R percent of 378 is extra. That is that extra 108 rupees you generate for compound interest over simple interest in 2 years. So R percent of 378 is 108. That is the difference. And from there you calculate R, and from there you calculate P. Clear? Let's go to the next problem. A coal borrowed 15,000 for 12% per annum, interest being compounded every 4 months. Every 4 months 4 months compounding means 3 times in a year. So, and the amount is to clear the debt. So basically, it will become, so if you remember the formula, amount E into 1 plus R by N. N means number of times it is getting compounded in a year, divided by 100. T into N. T means number of years. So that is when the compound of interest happens, not annually, but in a different frequency. In annually means N becomes 1. That means compounding happening only once. But if you see in bank, it gives you quarterly interest rate. So that is compounding happening 4 times a year. Now here they said compounding happening 3 times a year. So N should be 3. So N should be 3 means A is basically what you need to find. So this is 50,000. And then you have to do 1 plus 12 by 3 divided by 100 to 2 years into 3 times each year, so 6 times. So 50,000 to 1 plus 4 by 100 whole to the power 6. So this is one thing can do. And then, or if you see it from here, you can get 50,000 into 1.04 whole to the power 6. You can calculate it. Later you will get the value as 63 to 65. 0.9 or something like this. So you just need to calculate. So there is a calculation part that you can do, but otherwise the crux of this problem is to tell you how to apply compound interest when it is not compounded annually or in a defined frequency. Right? Let's go to the last one for today. The simple interest and compound interest on a certain sum of money and certain rate of interest for 2 years are 18,000 and 19,050. Okay. So if I say again same, SI is 18,000. So that means 9,000 plus 9,000. CI is going to be 9,000 for first year, again 9,000 for second year, plus R% of 9,000, because that is because of this only the next year the interest rate is more. So can I say again the same way, R% of 19,000, sorry, not 19,000, R% of 9,000 is creating this difference between 19,350 and 18,000, because the second year is where the difference is getting created. So this is 1350 R by 100 into 9,000. 90. So R is 1350 by 90. And this R is 15% per annum. We say find the if the rate is increased by 5%. So that means the new R has to be 20% per annum. Find the difference between the simple interest and compound interest for 2 years. Okay. So 20% per annum. If your so your rate of interest is 20% per annum, right? Now, if first you need to calculate, then you need to first calculate what is going to be the difference is created because of the first year's interest amount. The first year interest amount is itself not going to be 9,000 anymore because the rate of interest is changed. So at the rate of 15% per annum, your first year interest rate was 9,000. So apply that logic and see the principal if you can find out, because that is constant in the first case and now also. So if 9,000 is my interest rate in SI in the first year, I have to find out principal. Previously, the interest rate is 15 for 1 year. This is 100. So 15, this is 600. So your principal is 60,000, right? In the second case, your interest rate will become 60,000 into 20% per annum into 1 year by 100. So 100 cancelled. So your interest becomes 1,200 rupees. Sorry, 12,000. Interest becomes 12,000 rupees. Now, if your interest become 12,000 rupees, this is the delta that is going to be created. So the difference, they are asking for difference. So difference will become 20% of 12,000. Because the first year, it's going to be same. It's 12,000, 12,000 for both. So in the next case, first year, it will be 12,000 for just a minute. It will be just write a short one, 12K for both SICI. The next year also 12K here. The difference will be 12K plus R% of 12K. So this R is now 20. So this 20% of 12,000 is what you need to calculate. 20% 12,000 is 2,400 rupees. So this 2,400 is your answer. Clear? So that's how we are going to calculate SI and CI. And so I think we have covered almost 8 problems. I hope things are clear. We haven't got into too much calculation level intensity in this session. We tried to focus on the fundamental concepts and how to apply those concepts in the given scenario. And that's how we tried to solve the problem. Hope things are clear. If it is not clear, please feel free to drop a note. You can mail me also. I'll put the mail ID in the description box. And if you need any help, any guidance, we can take in. So if you like this video, share and subscribe. It will be helpful and motivating for me. So please do that. And we'll meet you next time in the SICI session 2, where we will talk about the advanced level problem. Hope you have a good time. See you next time. Bye.